Okay, so the next thing we need to talk about on the subject of functions is what we call domain and range. So the domain of a function is the x values that that function exists for. And because your input then determines your output, the range is determined by what the domain is of the function. Okay, so I'm going to show you an example using this one here. So this is sine of x. Now I'm going to type this in again. Say f of x equals sine of x. But now I'm going to put in some requirements for this function. And I hope this is going to work because I can never quite remember what the notation has to be. So I'm going to say this is going to go from -4. X is going to be bigger than -4, and we'll say equal to and less than 2. Okay, now if I turn my original one off, okay, there we go, I can see it there. So I've restricted the value of that function. Okay, so the domain is the highest value of x and the lowest value of x. Now, if I turn this one back off again and go back to my original, this function, we would say the domain of this function, because if I keep zooming out and zooming out and zooming out forever, right, it just keeps going. It repeats forever, and regardless of what x is, it's just going to keep repeating until it's just going to keep on repeating and repeating. Oh, what have I done to my screen? This is terrible. Sorry, guys. It's just going to keep on repeating and repeating and repeating forever. So I would say that this function, the x values, the domain exists for all real values. It goes on forever. Okay, I'll explain a bit more about what I mean by that in a second. Okay, so when we're writing our domain and range, we use what we call set notation. So this is set notation because you're using inequalities to define that. And when we're writing it, we would say x is the set of, and then the x exists between those values. Okay, so if I go to my notes, so here's some notes on domain and range. Okay, so here's a couple of definitions first. So the domain refers to all the input values of x to a function. Okay, so all of those input values. The range refers to all of the output values of a function. So, and again, that is like dependent on the input. Okay, so they're your two main definitions. I need you to put those in your book, please. Okay, so if, for example, we have f of x equals 4x minus 2, where x is equal to 2, 3, 5, or 10, what is the domain that has been defined for this function? Okay, so just be careful, there's a bit of notation going on here. So then we would say that the domain is the, oh, lost my pen. It's the set of, these are special brackets for sets. So the set of x, where x is equal to 2, 3, 5, and 10. Okay, now these brackets say that stands for the set of, so we'd say the set of x. This little line, that stands for such that. So it's the set of x such that x is equal to 2, 3, 5, and 10. Okay, now the next thing is we want to work out the range for this function. Okay, so we need to work out what each value is equal to at that particular point. So f of 2 is 4 times 2 minus 2. Okay, so that's 8 minus 2, 6. We would have f of 3, so that's 4 times 3 minus 2. Okay, so that's 10. Okay, f of 5, so that's 4 times 5 minus 2, 18. And f of 10, 4 times 10 minus 2, 38. Okay, so now for range, range is the y value. So we use the exact same notation except we have y instead of x. So we say the range of y is the set of y such that y is equal to 6, 10, 18, and 38. All right, there we go. Okay, so that's your domain for that function and your range. Things become a little bit more complicated when we put in an inequality. You will rarely find domains for functions where you've got discrete sets of x values, okay? Because that's really just looking at 4 different points on a graph. What's more common is if, like what the ones we were looking at before, where we want to talk about all of the values between a couple of points, okay? So all of the values between a few points. Now, if we go back to this one here, so our equation is 4x minus 2, okay? And we're told that x is greater than or equal to 10. So this is our domain of our function. If we want to work out the range, okay, if we know that x is the smallest value that we're going to have, we take f of 10, that's 4 times 10 minus 2, okay, which again is 38. So we would say that y is greater than or equal to 38. Now we know it has to be greater than or equal to because we've got a positive gradient. So if our line's looking like this, as x is increasing, y is also increasing, okay? But be careful about that because that might not always be true. If that was negative, then we would have y is less than or equal to 38, okay? You can also write this as, and you might see it written like this as well, is y is the set of all values, which is y is greater than or equal to 38. Okay, that would be that point there. 38. Okay, cool. All right, next one. We've told that f of x equals negative 2x plus 3, where x is greater than or equal to 4. So again, the range for this function, now we've got a negative gradient. So in this case, our function's decreasing, it's going down. So f of 4 is negative 2 times 4 plus 3. Okay, that's negative 8 plus 3, which is negative 5. So that means at that point there, where x is 4 and y is negative 5, that's the highest point, and now we're decreasing because the gradient's going down. Okay, so our range is that y would be less than or equal to negative 5. Okay, and again, you can write that as the set of values where y is less than or equal to negative 5, like that. Okay. Next one, we've got f of x equals 2x all on 3. Now, even though this doesn't look like a linear equation like it is above, it is a linear equation because you have your x plus a constant and it's being divided by some value. So you still only got one single value of x. So this is still going to give you a straight line, and the gradient is still positive because that x value is not negative. Okay, now we're told in this case that x exists for all real values. So this is like the one I was talking about before in GeoGebra. That one there, where you have, it goes on for infinity. So your domain exists forever. It goes on forever and ever and ever and ever and ever. Okay, and hopefully what you can see, if I go in and I draw this graph in here, this is the one we're doing on the street, so I might call it g of x, and it's x plus 2 all divided by 3. I'm pretty sure that's what it was. Ooh, okay, so we can see it there. Again, as x increases, y increases, and it goes on forever and ever and ever and ever. Okay, it's never going to stop. So x exists for all real values, and your y value also exists for all real values. Okay, so in this case, your y, your range, also exists for all real values, and that's what that means. And it technically means if you're drawing it as a set, it would mean that you're going from negative infinity, okay, to positive infinity, right? It's everything on the number line, okay? Again, you could write this using more formal set notation, so you would say y is the set of y such that y exists for all real values, okay, like that. All right, next one, a little bit trickier one. We've got f of x equals x squared plus 1. So if you're imagining this again on a graph, okay, you've got x squared. Now you know that looks kind of like that, and you plus 1, so it's moved everything up 1. Okay, so that's a little bit what that graph looks like. Now you're told that x is, x is greater than or equal to negative 2. no, x is less than or equal to -2. No, wait. Yeah, okay, so x is greater than or equal to -2. So what you're doing here is you're cutting off your quadratic graph, okay, at -2. So you're getting rid of all of this bit there. That doesn't exist anymore. In fact, I actually have an eraser to do that. Okay, oh, gosh, damn it, now it's gone. Okay, here we go. I'll just draw it back again. Okay, so you're cutting that off and you're seeing what happens there. Okay, so at that point -2, f of -2 is equal to -2 all squared plus 1. Okay, so that's equal to 4 plus 1, which equals to 5. Okay, now you should kind of see here that that's not the lowest point on the graph. Okay, so that's your point -2, 5. Now the lowest point you get to is actually that point there. Okay, so you can't say that y would be greater than or equal to 5 because that's not true. It goes below 5. Okay, so that's not true. So your range is actually that point there is 0, 1. Okay, and so that's the lowest point on that graph. So you would need to say that y is greater than or equal to 1. Okay, now it doesn't matter that this side cuts off because it's symmetrical and that side's going to keep going up and up and up and up and up forever. Okay, and again you could write that as y is such that y is greater than or equal to 1. Okay, and there's your set notation. All right, we're just going to leave that there. Now, just so you know, you do not have to know what these are going to look like. Okay, to do the domain and range, you're mostly going to be given graphs, and you'll just have to read it off. You don't have to know how to find the turning point or how to find those other points on the graph. So as long as you can read it off, that's fine. It's mostly just getting the notation right and being able to look at it and think about what's your lowest or highest values. Okay. All right, thanks very much. Bye.